So let's start now with the flow simulation using a single medium model. That is the most simple approach. The single effective medium approach tries to estimate a permeability enhancement in relation to the presence of fractures. So rock matrix and fractures are combined in one single medium that is homogeneous and continuous within cells. The model is the same numerical simulation model used for matrix-only flow simulation, but cell matrix properties are enhanced to include the effect of both matrix and fractures as a single effective medium. So the single effective medium properties include both the permeability relevant to the rock matrix and fractures, as well as the porosity relevant to rock matrix and fractures. The fluid flow from cell to cell as a function of the effective single medium permeability and cell surface areas. However, in estimating the permeability enhancement, we have to take into account an important issue very often neglected, that is, fractures add permeability, they don't multiply it. This is an issue very often misunderstood and or neglected, but leads to a wrong description of the reservoir permeability. In fact, using a single permeability multiplier, we finish to enhance more the rock with the highest rock matrix permeability. While we know that very often the fracture intensity has an inverse correlation with the rock matrix porosity and permeability. So the permeability enhancement has to be added to rock matrix permeability and can be considered qualitatively as inversely proportional to the rock matrix permeability. So the kind of expected function to be tuned case by case is the following one, where beta is the permeability of the rock matrix value above which no significant permeability enhancement related to the fracture is expected. The estimation of the permeability enhancement can be inferred from empirical correlation, taking advantage of the available dynamic data that should already include the inverse correlation with the rock matrix porosity and permeability. The flow capacity index workflow is a possible approach, as well as the estimation of the fracture network permeability through the implementation of the fracture modeling, a discrete fracture network, and characterization. This approach should give information about also the anisotropy. That means the estimation of the ratio permeability fracture versus permeability matrix, considering the estimated fracture permeability in the three directions. But when to use the single effective medium approach, and when not to use the single effective medium approach? This kind of approach, a single effective medium, is recommended when little information about the natural fractures is available and a quick assessment of the overall reservoir behavior is needed. In case of expected strong fracture permeability anisotropy, that is generally the case for fracture reservoir, the single effective medium approach can be optimized, including the permeability characterization, the estimation of the discrete fracture network permeability, which however call for a more demanding analysis. Single effective medium model can so represent a kind of quick and dirty approach, but has the advantage of being simple, fast, and it fits in with the standard history match workflow for no fractured reservoir. This kind of approach has not to be utilized, on the contrary, when the reservoir performance are strongly governed by matrix fracture fluid interaction, like a rapid fluid movement of water injected or produced through fracture system distinct from matrix, or where mechanism has capillary inhibition or gravity drainage are present. In fact, although this event could be, at least in part, mimicked, addressed somewhat in the single effective medium model using pseudo-relative permeability function, the reliability of the results are likely to be questionable, not capturing the real physics of the event.